find the equation of the tangent to the curve let's make it 50. 50 times 2 to the x at the point x equals 1. So we're combining both concepts here in this problem so that we can make sure that we're clear about the steps that are required for that. Now, a tangent is a line. So anytime we talk about finding the equation of a line, the first thing that I want you to think about is that point-slope form. Y minus y sub 1 equals m times x minus x sub 1. That is really and truly the only thing that's really easy to write the equation of. There's math out there for writing equations of things that are parabolas, if you know enough information. There's math out there for writing equations of exponential functions, if you know enough math. But here's something we teach people in 091, how to write the equation of a line. And all you have to know to write the equation of a line is a point that's on the line and the slope of the line. So our point is x sub 1, y sub 1, and the slope. And that's why we call this little trick here the point-slope form of the equation of a line. So if we have enough information, if we have one point that passes through the line, and we have a slope, we can write the equation of the line. So getting the point is an algebra problem. Okay? It's the algebra and the calculus here. So the algebra is that the point that I need is 1 comma something, but I don't know what that something is at this point, at this certain time. So I have to do the algebra to find out what the y value is there. When I write this empty, the emptiness, where the value for x goes in is in exponent. So that makes this an exponential function. So you're still doing that classifying. So the one homework I put on there, there's actually two. There's two homeworks. There's one that's a homework, and there's one that's a walkthrough quiz. This is exponential function. And I'll show you something really different here in just a second, just to keep comparing that. Now that we're starting to get lots of different kinds of functions together, you have to know what kind of function you're looking at before you decide how to differentiate it. So, now this is the same thing here, Scooter. Because of the rules of order of operations, I have to exponentiate the 2 first, and then raise the 2 to the first power first, and then multiply that by 50. You know, the good old parentheses, exponents, multiplication, division, addition, subtraction that you may have learned before in a math class. Exponentiation comes before multiplication. So this exponent has to be computed before I multiply by 50. And so that's exactly what you're looking at on that paper too. So here we actually get 50 times 2, so our y value is 100. So the point is 1, 100. Okay, so you have to evaluate the original function at 1. Okay, now don't get your y's and the y's here confused with the y's. Maybe I should go back through here and write this in function notation. I put y. That's a way to write a function, but I bet if we do this, you'll like that better. There's f of x. This is f evaluated at 1. The function evaluated at 1. Okay. So that's the algebra that we need. Now we've got to do the calculus. And to do the calculus, we have to know what kind of function we've got. And we've already classified that. My base is 2 only. So see, I could not write this as 100x. Okay? That's the temptation, is to write that as 100x. But you don't get to multiply the 50 times anything until you figure out what you're going to take 2 to first. 2 is the only thing that's the base. You've got to take 2 to some power and then multiply by 50. And if you do it in a different order, you're going to get a completely different function. Okay? So, as we go through and do the differentiations, look at the notation we're going to use here. There's our f prime notation. A couple questions came up this past weekend. You know, what about this 50? Does that 50 is not a term by itself. That 50 is a coefficient. So we talked about the fact that coefficients can come across the differentiation. So we have this for our next step. And what this is showing us is it's 50 times, when I want to differentiate f, I want to find f prime, 50 is a coefficient, it comes out front. It's not a constant. It's not 2 to the x power plus 50. That's very different. This is 50 times 2 to the x. So 50 comes out front, and then we have to differentiate 2 to the x. Now, you need your formula sheet. I hope my computer is working. When I first came in this morning, it wasn't going to load up, and I have formula sheets I want to print out, some other printouts I wanted to make for you today. So I have to go figure out if it's working. So something from last time. Is there any place in your notes from last time that you can find what we would do to differentiate 2 to the x power? Okay. Natural log of 2 times 2 to the x. That is the derivative. We found out that the derivative of e to the x is always itself. If it's a to the x, it's the natural log of that base times itself, 2 to the x again. So it's just a little bit trickier. Not much. Okay. So, and that's as far as you can go. You could, you could find the natural log of 2 on your calculator, and you can multiply it by 50, but you're going to have to round. So I don't really want you to do it here. If you want to name the derivative, leave it as natural log of 2. That's still a number. It's just not in its decimal form, and that's okay. Now, to find the slope, we're going to have to evaluate this derivative at a value x equals 1. And that's where we'll end up with our, let's see what we get, 2 to the first here. That's where we'll probably either leave it as much as we can or get a decimal approximation. Okay, now when we look at this as order of operations, it's 50 times the natural log of 2 times 2 to the first power. 2 to the first, we've got to do exponentiation before we do any multiplication. Well, 2 to the first is going to be 2. And then 2 times 50 is going to be 100. Now, why can I do that? Because this is multiplication. It's 50 times natural log of 2 times 2 to the first. And multiplication has that feature of being commutative, meaning it can change order. And I can write this as 100 times the natural log of 2. If I don't want a decimal, I can leave it as 100 times the natural log of 2. It's a number. That's still my slope. Okay? So I don't have to get a decimal. And most of the time we don't want to, not unless it says something about getting a decimal approximation. All right? So now do you know how to finish the equation? Because now we have the point. Remember what our point is. The point was 1, 100, and the slope was 100 times the natural log of 2, which is a number. There's no x's or y's left in this, not an equation anymore. It is a number. So point slope leave y as our variable. Y minus 100 equals 100 natural log of 2, which is a number for m, times x minus 1. You can distribute this thing through just like you can any number. Even if it was 7x, you would have 7x minus 7. So now you have 100 natural log of 2 times x minus 100 natural log of 2. Because I just distribute here this number. Just think 2006 here. This is a number. times this, that same number times -1, add 100 to both sides. You're just going to have to tack it at the end. Even though 100 is also a number, since I didn't get a decimal approximation for that, I'm going to stop there. Otherwise, I'll have to get decimals. But that's okay. There's nothing that says we always have to get decimal values. This is kind of one of those things where if you leave it this way, this is actually the cleanest version of it. You can get a decimal for this, but this is the exact value if you don't get a decimal. You leave it in exact value form. So that's another one for finding the equation of a tangent. All right.